Okay, for number 4, the bars are not isolated, so we need to do that first. Now we're ready to decide. This is a less than, so we need an and. So when I write my cases, and we know we're going to get a sandwich, flip it, switch it. So P is less than 28 and P is greater than negative 10. Negative 10 would go here. 28 would go here. There's no line under the inequality, so open circles. Less than 28 is this way. Greater than negative 10 is this way. And we got a sandwich, just like we expected. Okay, number 5. This absolute value is being divided by negative 2. We need to take care of that first. Okay, so if I want to get rid of divided by negative 2, I need to multiply by negative 2. On the left, those cancel, leaving me with just the x minus 2. Negative 6 times negative 2 is positive 12. Okay, now we are ready to decide. Oh, no we are not, because I messed up. We multiplied by a negative number. Anytime you multiply by a negative number, flips. Okay, and so we still have positive 12 over here, but our inequality flipped right at the beginning, before we even took these bars off. Okay, and so now, even though the original was a greater than, we don't look at that to decide if we're using and or. We look at this one. And so this is now a less than situation. That's why you have to isolate the bars before you decide and or. I'm going to say that again. You have to isolate the bars, then decide. Okay, and so I'm looking at this step to decide less than, and so and. So now when I write my cases, x minus 2 is less than 12 for my first case, and x minus 2, flip it, switch it. Now we're back to Algebra 1 territory. No more flips necessary. Okay, and so this is an and, so I should end up with one interval of shaded numbers. 14 would go here, negative 10 would go here. We need to open circles. It says less than 14, greater than negative 10. Sandwich. All right, here we need to isolate these bars. Don't do anything. Don't write your cases until these bars are isolated. So you have to add the 4 first. Whatever's not attached has to go first. And then divide by 2. All right, so here we are dealing with absolute value and we have a negative sign. Anytime you run into absolute value compared to this negative sign, and this means I've isolated first, because here we had a negative, but after I isolated, it got taken care of. Here I've isolated and the negative did not get taken care of. And so this is asking me, when is absolute value greater than a negative number? Don't do anything else. It's all real numbers. The whole number line is shaded. Okay, absolute value is always positive because it's distance. So my left-hand side of this inequality is always positive. It doesn't matter what I plug in for x, it's always positive over here. And I'm asking, when is a positive number greater than a negative one? This is always true without even solving anymore. Okay, if I had the situation, whatever's in here, less than negative, no solution. Absolute value will never equal negative. It will never be less than negative. If I have absolute value greater than negative, all real numbers. And so this includes negatives, the equals. You can't be less than or equal to, you must be greater than a negative. And then you can have all real numbers.